Okay, yes, Varun, you were telling about why do we. So my question to you was, why do we have a separate this thing storage layer when we do have an application server layer database? Mm-hmm. Mm-hmm. Okay. Talk about only one particular service. Over here, we are only taking one particular service. That is one microservice. Okay. So let's talk on in that frame. Yeah. Tell me. So what points do you have? Mm-hmm. Right. So basically data loss, that is one of the key features, data loss. We cannot afford data loss for to any company, right? Any company cannot afford this. So major point, data loss. Any other point? So just think in this way, your application server, what it does, it has the business logic associated to it, right? You don't want your business logic. That means business logic is something that is a very smartest solution of your entire microservice, right? You are writing the most smartest thing, and now your business logic should not be interfered with the data, whatever customers data that you are interfering, right? So application servers duties only to ensure business logic. They are not concerned about data and all that, right? Data can be varying everything, but your business logic is something very generic. They will depend on the data, whatever incoming and outgoing data. So basically whatever you have just said, right, your application server goes up, goes down. So they keep, this keeps on happening in each and every day. There are so many application server which goes down, something or the other, it does happen. But in that cases, if our data also resides there, we cannot afford data loss. That's a very important point. In fact, this is the most important point. And second thing is that we don't want to interfere our application logic with the data layer, right? So that is the reason we do have a segregated application layer and the data layer, right? Right, exactly. It's a separation of concern. That's the correct word you have used. So that's the separation of concern of each and every layer, right? So now think and also remember this part. Your application server is the most smartest thing out of this architecture. You know, even though your load balancer and API gateway is also an application server. So they are the smartest person throughout this entire architecture that I've drawn. And database is the most dumbest thing you see in this one, because its duty is only one job, that is to store the data. That's it. It's to store the data and persist it. The database only job is to store the data and keep on persisting. That means you have just one duty, just keep storing the data and keep persisting it. I do not want any data loss. Okay, so that was the major separation of concern that we did regarding the data storage layer. So that was about the storage layer. Okay, so now comes an important part over here. Application server layer, how do we scale the application server layer? Right. Can you give a, yeah, can you give a generic term to that? So over here we'll talk about. Mm-hmm. Right. So horizontal. So if scaling an application server can happen in two ways, one is horizontal and one is vertical. Right. So now what's the difference between these two? Hor- Mhm. Exactly. Add more instances. That means the same replica of instance that you are running, you added one more to this. So for example, in the above diagram, this is instance one, this is instance two. So we have added another instance to it, right? So that is an horizontal scaling. And what is vertical scaling? Mm-hmm. Right. Right. Exactly. So basically, it is called making the size as a bigger, right? So this is also called scale out. So you might be hearing this a lot. So this is a scale out feature of your application, and this is scale in. That means you are scaling inside the same hardware. You are more making it more and more bulkier. So what's the advantages of horizontal scaling? Can you think? And what's the disadvantage of both of them? What do you think of that? Mm-hmm. Okay. Mm-hmm. Right. Right. Very good. Mm-hmm. Less highly available, we can think of that. Right. Less available, or okay. Okay. And what else? So you can, in horizontal scaling, you can scale out infinitely. Can you think of that scenario? Right. Servers. Right. So you can scale infinitely over here, but in case of vertical, you cannot scale the infinitely. Right. What else? Auto scaling is a feature that we can use. We can scale up, scale down. Right. If we do, if there is a very less traffic during the night time, I won't be charged that much. But in case of vertical, you can't do all that. Right. Auto scaling. Do you know what is auto scaling is? Yeah, exactly. Okay. Correct. So it, right, dynamically, right? So our revenues will be impacted due to this, right? What else can you think of the differences? So these are the mostly the high level this thing, right? And what's the advantage of vertical scaling? We have only talked about the advantage of horizontal. Now if we have vertical, what is the advantage? So I'll tell you this also. In just think, you have just one server. You need to deploy your application only to one server, right? Deployment only to one, right? Only in one server you have to deploy. You don't have to deploy in all the server. In microservice architecture, currently we deploy in all the four server. One, two, three, four. In this above diagram, you have to deploy your application to all the four servers. Then only it will happen, right? So deployment, yeah, exactly. Deployment is easier over here, right? And in case of this one, deployment is time taking. Now again in the next point, this is a very important point. This is very important point of horizontal scaling. Just remember this point. So have you heard of this term, SPOF? You will be hearing a lot in microservice architecture. SPOF stands for single point of failure. So that means in vertical scaling, you just have one application server. If that goes down, your entire microservice goes down. But in case of horizontal scaling, your application server is not a single point of failure. For example, in the above diagram, if let's say this one goes down, S3, the other servers are still running and they will be able to cater to your requests. But in case of vertical scaling, that is not possible, right? Understood? Okay, so these were the major pros and cons of each one of them. Okay, in most of the cases, we use horizontal scaling. Okay, vertical scaling is used in very less, I mean, in microservice architecture. Just remember these pros and cons, because in places you will be asked, why would you prefer to go for horizontal scaling? So you can list down these points. Okay, so now this was about the application servers, right? So same scenario happens to DB also. This also applies to DB. Okay, so in case of databases, your application servers did this thing, right? But in case of databases, they also scales out. Okay, so now why would your database be scaling? Do you know for any reason why your database should scale? Exactly. I mean, the same. You are getting a lot of data. Now you cannot store in a single node or a single database. You are going to scale that out, right? So databases also expand in the same way, horizontal and vertical. Now over here, we are not concerned about SQL, no SQL, anything sort of that. Okay. We are just talking about the generic databases in general. okay, data store or the storage layer we are talking about. Okay, let's not be concerned about SQL, no SQL and all that. They have different terminologies associated to that, that will cover up after some time. So for now, just remember your databases should scale, because only if your application server will scale out, that means your data will become a bottleneck at some point. So you have to take care of scaling the databases also. You know what's the most interesting thing over here? So the most interesting thing about the microservice architecture, whenever you are bootstrapping your microservice initially, in 99% of the cases, your database will be scaled up already. Okay, your databases are already scaled up. That means in the initial architecture itself, the architects takes this into consideration. Let's take a huge database, and let's after some time then we'll think about scaling out and scaling in. So in most of the cases, your databases scaling is already been taken care. So in, because data is very cheap, data store is very cheap. So initial level, we go on and takes a huge database, and we can think that everything will be taken care. Okay, so we, in most of the cases, our concern should be only of the application server, because they are expensive resource. In case of data store, we don't generally talk of that, but we do have to talk about what are the mechanisms of data scaling, what happens in case a data scales and all that, right? So in data, while scaling up the database, we generally talk of two terminologies. You might be hearing this a lot. One is called sharding, and the second one is called partitioning. Have you heard of these terms before? Mm-hmm. Okay, no worries. We will study about that. So in databases, whenever you are scaling out the data, we will hear this a lot. Now, think of this. What is sharding, and think of what is partitioning. Okay, now let's talk about partitioning first. So in partitioning, what happens is the name, you can refer from the name. So partitioning means you have your databases, and inside the databases you have various tables. For example, you have users data in one users table, you have orders data in orders table. Okay, for example, we are for now we are concerned of, so just remember this is only for one particular microservice. Okay, one service has these data. Okay, orders data. In a most real case scenario, your orders should be in different microservice actually, and your users related in different microservice. For example, users related data, for example, you can think of, let's be concerned only of the particular users, and let's say users likes, users dislike. Just remember these are some random names I'm taking. For example, just you can think of these are related tables, okay, for a particular service. Okay, I'm taking users only because in that way you can think that it is related to only one particular service. Okay, nothing sort of orders. Let's take order also, but in reality, order and users will be a different service altogether. Okay, but for example, let's say they are related somewhere, something users are making an order. So now in partitioning, what happens is your tables are segregated into different nodes. So for example, you have a database over here. For example, you are taking a MySQL database. Okay, so now initially all your data resides inside this one. Okay, so now after some time you see that your data has scaled so much, now it is not fitting into this one. So now what you did is you are making, you are you are this thing, you are creating another database now. Okay, and now over here what you are doing is, this is db node 1, db node 2. So now what you are doing is you are making that your users data, your users table resides over here, and your user likes and dislikes table. So this is the entire table we are moving. For example, orders data also here. So the entire table of orders users are residing in this one, users dislike and residing in this one. So now what is happening is you have two separate nodes, and then what is happening is that users related data is persisting onto this one, orders related data is persisting onto database one, node 1, and in all this and in database node 2, your data related to this is flowing, right? Tables, yeah, different database nodes. Okay, different databases. Okay, so important part over here is they are separate. That means user like is a separate data compared to users. That means how your users data would be username, ID, and all that, right? User like would be user one is liking this content ID and all that, right? So they are two different uh, data kind of, right? They are entirely different because they are two separate tables, right? Yeah, you can join it using foreign key and all that, right? You can join it. Okay, in general cases it is joined only, right? User ID is having user ID, user likes will have user ID as well as the likes of the post ID, right? Kind of that you can think of. Mm-hmm. 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 So you have to make your join between these two tables, right? So one table resides on this node, another table resides on this node. You have to do an aggregation and all that, right? Yeah, yeah, so we will come to that. That's a very complex thing that you have just talked. Okay, in general cases what we do is we will not do across nodes join. That means this is node 1 node 2, right? And this is a cross thing that we are doing, right? So we won't, in real case scenarios, microservice will always, I mean, will make sure that they will not be doing across joins. Just remember this. Okay, in our case we have somehow made it. Okay, but in reality this will not happen, right? Okay, so now so this was about the partitioning. Okay, now let's talk about sharding. Now in real case scenarios mostly sharding is used. Okay, I mean in most of the cases we do have partitioning also, but just remember sharding is the most widely used one. So now in sharding what happens is you have your database over here. For example, users data is coming. Okay, in this one your users data is coming, whatever users related data that is incoming. Now the db is such that it has exhausted limits and everything, and now we want to scale this out. So now the way we scale this out is we add one more database node. This is node 1 and this is node 2. Okay, so now what happens is, so if, for example, you have t amount of data over here, and now the same data is segregated into two. That means the same table's data is segregated into t1 and t2. So now your t is equal to t1 plus t2. Okay, your user's data half is present over on t1, half is present onto t2. Now how we have segregated is, that means for example yours data is there, user id 1 Varun and your related data, 2 Sushil my related data, 3 Vishal some related data, 4 Rishabh some related data, 5 for example Y some related data. So we'll make sure that on any segregation mechanism, for example we are segregating on the basis of first letter of the name, right? So for example in this database a to, yeah, yeah, right, yes. So that means your first letter starts whenever with a to n will reside in this one, and l to z will go in this one. So this is one one such mechanism that I've just said, the way you can shard your data. That means the way you can divide your data. Over here if you see the same tables data we are splitting, right? We will talk about the way we have sharded this one is on the basis of this, the first letter of the alphabet of the name, right? That is what is called sharding key. On what key are we sharding the data? Just remember this term, very important thing. Sharding key, on what basis we are splitting the data. Partitioning versus sharding. Clear? Any doubts? Okay, so now with these terms, just remember the way we scale the databases are mostly in two terms. We talk of scaling the data. One was sharding and one was partitioning. So now the way we do is, I mean, in real life scenario, how companies scales their data is they generally divides the data into two. I mean, in any system, you will see there are two such cases. One is called a read heavy system and one is called the write heavy system. That means whether your system is a read heavy system or a write heavy system, on that basis you are going to scale your data. Okay, and now remember we won't be talking about partitioning a lot. Okay, in every future classes we mostly be talking about sharding now. Okay, partitioning very less happens because partitioning happens at the service layer, and that might have already happened at the service layer. Inside a particular service, we talked about sharding now. Okay, so partitioning happens at the microservice layer, which would have already taken place when the services were distributed to each and every team. Okay, okay, now let's talk about inside a particular microservice. We generally talk about two terms: a read heavy system and a write heavy system. So what is the difference between these two? Right, that's very correct. That's the name in itself suggests. Okay, give me an example of any both of them. In what scenarios we can think that it's a very read heavy system, and in what scenario we can think of very write heavy system? Mm-hmm. 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 Right, read heavy. Right, read heavy, because most of the time, exactly, we'll be reading it, right? So you can think of that. A blogging site is a read heavy system. Very correct example, right? Any other you can think of read heavy? Right, these are all read heavy system because mostly, yeah. But imagine this thing: blog site, not millions of users would be requesting the same. So think of in terms of e-commerce application, because that's where the mostly the traffic comes in those cases. Okay, your point is absolutely correct, but that will not make much sense for our use cases, right? So you read heavy system you can think of in an big billion day. For example, a number of users, right? A particular product price has gone down, so the particular product price has gone down, so many users would be trying to place an order, right? Those are write heavy system, right? Whenever we are placing an order, those will be write heavy system. When it will be write heavy system? Only when people are placing the order, that would be a write heavy system. But the same system will also be a read heavy system because the price is very low, so many users will be reading. So in that case it is both read heavy plus write heavy system. Read heavy system you can think of something like same in a big billion day, right? You are just, I mean, people will just navigate through the pages, right? What are the offers those are running? So in all those cases you can think of the read heavy system. Okay, right. Hmm. Read heavy, write heavy, yes. Yeah, based on scenario. In most of the cases we do have both the scenarios. Okay, read heavy, write heavy system, read plus write heavy system. So we deal with these systems in a very different manner. Okay, in a very similar manner, but in a very different, not a very different, in a very similar manner only, I would say. Okay, so what happens in a read heavy system is, so how do we scale out the data? How do we make sure that our users does not face much downtime and they reads, I mean, the reads are very much quicker, right? So over here the application servers are there. You have already scaled that up now, right? And you have a load balancer layer over here which will manage the load between different database, right? For example, you are just running a single database. Okay, in most of the cases we run a single database for our general use case, and we don't need a load balancer also because our application servers will go to this. For example, in our in the service which I am working, it just have a single database node. So in most of the cases you will see a single database node. Okay, and this itself is taking the reads plus write. Okay, this system. Now what is the problem if we take a single database? Talk in terms only when yeah, that's absolutely there. Single point of failure. Whenever you have anything singular, you always talk about single point of failure. This is a very famous line you can say in an interview, and they will be very much impressed also because this is very important thing to be taken care. Okay, yeah. So let's talk about read heavy and write heavy. Now think of in this term. Why to have we segregated read and write? What's the difference? What happens in case of database read? What happens in case of database write? Why have we segregated these two? Why? Yes, you are correct. You are absolutely correct. Now, what's the reason? Mm-hmm. Okay. Okay. right? So what happened? Okay, why does it take more time? Why does write take so long, but a read does not take that long? Simple answer to this is write is basically a transaction kind of thing, right? In transaction, you know, right? There's a something called lock that comes into picture. That means what happens is whenever you are writing something, right? So what happens is on the entire particular table or on the entire particular row or on the entire particular column, depending on our scenario, we are going to lock something and then only we are modify the table. So by the time the table has been locked, you are not allowed to read also, and nobody is allowed to write. So you are basically becoming a bottleneck to so many users now. For example, if I am making a payment, right? I am creating a lock onto a payments table now. All the other tables are also affected if I am taking a lock on the entire database. If I am taking a lock only on the payments table, so see, locking will happen depending on our scenario. Locking can happen on the table level also. That means the entire table can get locked. Okay, your entire row can get locked, or your entire column can get locked, even your entire database can get locked. Depending on the scenarios, you can lock. The reason we lock is because the transactions happen in such a way that they need a lock, otherwise the data inconsistency will happen, right? So that's the reason your write and reads are so much different in a databases. Your reads are just not modifying the data, so your transactions won't be affected due to that, and the database allows smoothly in such cases. Okay, so that's the major difference between read and write, and we do tackle these systems very differently now. Okay, so now let's see how do we tackle this scenario. Okay, so now the entire database, for example, one database was not enough, so what we did is we scaled out the data now, a database, sorry. And now let's say we have scaled out to two databases. This is db1, db2. Okay, now just remember, for example, the same data is there. Okay, that means we are replicating the data. Either go to this, if this is basically, it will go in a round robin fashion. First go to this. Important point to be noted over is this is the data replication. I haven't talked about data replication yet. Data replication means both the database having the same data. Okay, now how will it have it, all that we will discuss in some time. Okay, so now what important point over here is that for read heavy system, what you are going to do is you are going to scale out the databases, right? And important point over here is the database that you are scaling out, you are just replicating the entire data, right? This all are having the same data, and now your request can go to any of this application, any of this db, this thing, right? Let me draw it nicely. Were you able to relate what I was trying to say? Can you explain? Mm-hmm. 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 Replicate each of the database, right? That means, yes, yeah, exactly. So for example, just think in this way. You have node 1, database 2, database 3, database 4. Now you see your system is getting more and more read requests, and you want to scale out. What you will do is, out of database 4 you will scale out another database. Just it's for now, just think that database is doing on its own all this scaling out, or is auto scaling and all. Just for the timing, just think that they are doing on its own. So how will it do it? It will just create an exact replica copy of its image, and then will create a spawn out a new one. And then in for load balancer, hey, please hit me also, because now I am also available, right? So node 5 scaling has happened and database replication is kicking in, right? Important point to be noted. Okay, now this was about the read. So now, for example, a write request came in. What will happen in this scenario? Before that, remember this thing. Now the data is having exactly the same data, right? So now it was having the same data and everything was working fine. Why it will work fine? Because it's having the same data. You can go to any database and you can just pick the data. Now just think in this way, that now a write request has come, and now it has modified the data onto this node, onto node number 1. What would be the problem that I am facing now? Yes, consistency on what? Mm-hmm. The same data. The most recent data that has happened on one. Right, exactly. So now your consistency has been altered or halted due to this, right? So what solution can you think of now? What can we do? We can do, you can say we can do. Mm-hmm. 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 Right, right. But by the time they are communicating among each other, the database, a request has come to, let's for example, database 3, and there was no information that the latest write has happened, right? And it was a mhm. No, load balancer. See, in most of the system design, load balancer again are the dumbest person. They will not do all this important business logic and all these details, right? Okay. So now let me, yeah. So now there are two ways that we can do it. Okay. First is we can allow database in such cases, right? In such cases, we can allow databases that please synchronize among yourself first in case of write, and then only respond to the user, I have updated it. Okay, that is called a online propagation. I'll just write down a better way, just a minute. So two ways are there. First is you will allow, this is also called sync propagation. You will hear this a lot. You will allow, ask the database, please talk among yourself first. Whenever there is a write, then only this will case will happen, right? So just remember, whenever there is a write, first communicate to each and every node, then only respond back to the client, right? Now what will be the disadvantage of that and what will be the advantage of that? Very good. So we are getting consistency. Very important point, we are getting consistency. You have heard about cap theorem, right? Consistency, availability and partition. So we are getting consistency, partition is always there, so we will lose out on availability now, right? So you were just talking, I think you were talking on that point itself, right? Yeah, so our availability will go down, that means the latency of the system will go up. Why? Because now for a particular request, for a particular write request, right, for a particular, you have, I mean, you have understood about the read system, right? In read system, database were replicated in any node, they can go and they will just read it, right? So now we are talking about the write systems. Okay, so in write system, now it is communicating to each and every database nodes. So what will happen now? Your latency will go up for a particular request, right? So now it is upon us that whether we wanted the latency to go up, whether we want a consistent system or an available system. You see how beautifully your cap theorem is coming in picture into this place, right? So just remember this point, this was an online or sync mechanism where you are allowing the database to communicate with each other first and then only respond. There is another way also, that is called offline mechanism or an async mechanism. What does that in now can you think of what can be the scenario in that case? Yeah, in this scenario, let's talk of, in this scenario, for example, write has happened on one, what will happen now? Yes, they will refresh itself, correct. So what will happen is request has come to one, it has written the data down. Now after writing it down, it will immediately respond to client that your data has been updated and you can go back to sleep and do whatever you want, right? Now in the background, database will refresh itself, right, with the latest data. So now we are losing on the consistency. For example, immediately user makes a request to database 3, your data will be inconsistent, right? So depending on our use case, we are going to use this scenario. When will we use a sync mechanism? Can you give the name? You, no, not a sync, sync, that means an online. Right, 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 right. Transaction, banks, wherever you need a highly consistent data and all that scenarios, right? And in offline and async mechanism would be needed in case of social network where you won't be gathering needing that much consistency. You might see this in LinkedIn a lot. They uses an async mechanism a lot. Okay, so in LinkedIn you might be seeing a post sometime, a like has this many likes, after sometimes it just vanishes away. You have just like, you refreshed, it did not reflect, all this async mechanism. So LinkedIn uses an async mechanism a lot. Okay, that means the database is not consistent. In such cases, that does not mean that your database will not be consistent. In such cases, we make our system to be eventually consistent. You will hear this a lot. Eventually consistent means immediately it is not consistent, but give me some time, I will update the other nodes also and it will be consistent after some time. That is the meaning of eventual consistency. Okay. Yeah, okay. So this was one such scenario. Your read and write is having onto the same database node, right? So in case of read heavy system, if a write comes in, we do in such manner. Okay. So now in case of write heavy system, what we do is, just a minute. Yes. So in case of write heavy system, what happens is you have a client over here. It's a making a load. That's a normal, okay, API gateway, load balancer, your application server. In any system design interview, if you don't know anything, just draw this diagram. You will at least make sure to the interviewer that you know something. Okay. So now in case of write heavy system, there are, we segregate the database in such a way that this is database node 2, database node 3, database node 4. Okay, and now there is another layer over here which is load balancer. Just a minute. um, we have a load balancer also. What's the purpose of, what's the difference between this load balancer and this load balancer? I keep on drawing, right? Do you know the difference? Difference is basically one is present on front of DB layer and another is present in front of application server layer, right? That's the only difference, nothing much. Okay, there's no extra, same thing, just present in front of different thing, because we wanted our mechanism to be followed differently in case of application server. Why we want? Because we want our application server to be stateless. Important point, why do we need our application servers to be stateless and not stateful? And our database is always stateful. Can you I mean, have you understood what I just said now? Can you explain more on that part? Stateful, and application servers to be stateless, right? Mhm. Right, right, you are correct. But in terms of scalability, just remember, why do we want a stateless? Because we want our request to route in any of the machine, right? In any of the machine, because if we allow some logic in such a way that it does not go to any of the machine, that means we are making it stateful. And if we add more servers, if we are doing auto scaling on application server, that means we have to change the mechanism, right? Some data has to be transferred from database and, sorry, application server 4 to 5 and all that, so that it becomes consistent that application server 5 has this data. Basically application server should be stateless, because our horizontal scaling would be adhered to that. That means in horizontal scaling we are spanning up more requests, right? And we don't want any data related logic to reside at the application server layer. But whereas in database, its duty is to store the data only. And we cannot say that the data of this user should reside in the database 1, and you can now search in database 2. There is no point of searching in database 2, because it will not be having. Database duty is only to store the data, and that is stateful only. Data and stateful are same, just remember this term. Okay, database is always stateful because its duty is to store the data. Okay, if database 1 has the data, that means it should be the request should always be routed to database 1 only. You cannot route to any other database, otherwise it would be just a wastage of time, right? So that's the difference between stateful and stateless. Exactly, and it's just wasted of time for the request, right? And bad user experience. But in case of application server, no such things will come in. You can route to any application server, right? And the reason we do is because our horizontal scaling and infinite scaling and all that things can easily happen if we make it stateless. Just remember these terms. Okay, database is always stateful. Okay, now important thing over here is that in case of write heavy system, so in the previous scenario, what we did was, in the previous system what we did was a read and write is taking on the same database, right? And now what we have done is we have just segregated the data which is having more power. This is having more power, more CPU and some extra resources we have added it, and we have made it in such a way that our write will happen only to this particular database, which is db1 over here, and our reads should always happen on 2, 3 and 4. Understood this point? So that means your write request will always go in this database, and your read request will go into these databases. Now important question to you is this: why have we segregated the read databases and write databases? Mm-hmm. The read request, right? Because your read request can go onto your database 1 itself in our previous case, right? So in database 1, why don't we make it only for write request, right? Because in most of the cases, for example, you are making a payment, right? People are expected to wait. That means they can wait because they need a consistent data, right? They can wait. But in case of write also, if they are going to wait, if for example you are refreshing an Amazon website and somebody else is purchasing it, and by chance you have hit the same database 1, right? It would be a bad user experience for the person who's reading the data or just refreshing a data a page, right? So that person might be affected. So for such cases, for example, you are making a payment, I am making a payment, both are hitting the same database server, I am also fine, you will also be fine, because you want your data to be consistent, payments related data. You can wait in that case, people won't be offended. But I am just refreshing the page, and in the same database I am hitting for refresh also, where you are making a payment, you can wait but I cannot wait. That would be a bad user experience for me, right? So for that purpose we have segregated the read database and the write database. Your read request will only go to 2, 3 and 4, and write will go to only database 1. Understood till this point? Now important question is, what data is residing onto database 1, 2, 3 and 4? Just I am telling you this thing, they are exact replica of each other and they should be replicated, right? They should be replicated. Now just think in this term, writes are happening on db1 and your reads are happening on db2, right? Same problem, don't you think will occur over here also? Read, async and all that we have just discussed. Yeah, they should, exactly, right? Now data should be replicated the way they basically whenever a write has happened, right? So it's the duty of this write database to communicate those changes over here also, to these databases also, right? Don't you think it's the duty of this write database to make sure that these databases are replicated, right? So again, that can happen in two ways that we have just discussed: async and offline manner. Same thing will happen in an async manner. What will happen, in the background, it will just in case of a write request, we'll just respond it to the user, database is, data has been written, now you can make a read request. But in the background the data will keep replicating and refreshing and updating itself. So reads will also be, I mean, write will be making a propagation to 2, 3 and 4 and making it the most recent versions. And in case of a sync mechanism also, it will do the same, right? The same thing will happen. It's just that we have segregated the reads and writes now. For example, now you are having a more and more write request. That means the number of writes you were getting was x initially, now you are getting 2x state amount of write. What are we going to do now? What's the proposal that you will give? Hmm? Simply scale out dv1, right? Exactly. No, there's no point. You are just getting the read writes to be multiplied, right? So just think in terms of the write database. You are going to scale out db1 to, let's say, db5. You will create an exact replica. Now your writes can go to any of the database, either from to 1 or to 5, right? So at this layer, just a minute, I'll draw it over here. So you have db5 over here. This is only writes are happening over here. So now write can go to any of these nodes. For example, yellow is for write either to this or to this. It can happen or to this or to this, right? And now you do it is making our system complex, but in a way it is also scalable also for our system. Depending on our use case, we are scaling the things out, right? In most of the cases, I assume that 2 or 3 writes database should suffice, but as per the situation, it can go up and down. Okay, so this was about the read heavy and write heavy systems. Any questions or anything? Any doubts? Yeah, tell me. Mm-hmm. In case of mm-hmm. We have done the same thing, right? I mean, I didn't get your question. Can you repeat? Mm-hmm. See, read heavy, write heavy, it's just a terminology. Actually, whatever you are saying, we have just did the exact same thing over here, right? Out of this 5, I have just picked up this database and made it read, right? And brought it in front. That's it. That's the only thing I've done. That's what we are doing, right? Nothing extra I have done. I have just picked up database 3 now, cleared it, formatted it, made the replicated, and just made it only for read systems. Sorry, write systems. You take the request. That's it. That's the only thing that we did. Nothing extra fancy we did. This was just the naming convention: read heavy, write heavy. Otherwise, yeah, you can think of that because in case of read heavy system, the number of people writing would be very less only. Very less, you can think. Not in case of e-commerce. Yeah, exactly. That's the important thing. Yet waiting time is acceptable. You can think that customers can wait. Your right is not having something complex in that case. For example, banking and payments are complex. They make app to request to third party apps, and then bankings are also involved. Payment processor, they kind of takes a lock for a longer time. For example, you are just making a very small kind of update, very small, that only for a certain milliseconds you are making a lock. So in that cases we can afford, right, having the read and write onto the same database. Okay, so in such cases, this database itself, this database of write is called the master. Okay, and this is called the slave. And this is a classical example of master slave architecture. You will hear this a lot in case of databases. Okay, master slave architecture. You can have multi-master, multi-slave architecture. Masters are replicating, that is called multi-master. Slaves are replicating, multi-slaves. Both the combination, master slave architecture, multi-master, multi-slave architecture. You will hear this a lot in fancy terms of this thing, in system design. Okay. Okay, so now we have read about this also. There is something called lazy propagation and eager propagation. The same thing. Sync is also called eager, matlab turant, early, and this is also called lazy propagation after some time. So they are used. Yeah, exactly. They are used in a acronym manner, synonym manner. I'm not sure what's that. So eager online or sync are same. Lazy offline and async are same. Okay, in case of your this thing, I'm not sure in Python what do we use for database connection. In case of Java, we have something called hibernate. We uses this terms a lot: easy initialization and lazy initializations of data. So that means whenever your system bootstraps, your database, your data member variables inside Java, will have those data automatically fetched from the database initial level. That's a eager initialization. You might be having the same thing in Python also. I'm not sure which framework do you use for databases. You would have heard this term a lot. Okay. Okay. Hmm. Right. So now, hmm. Okay. So now, so this was one scenario, right? Now consider this scenario that you have so many databases over here. You have DB1. Let's write it down. You have DB1, you have DB2. Similarly, you have 10 database like this. Okay, and these are all read heavy system. Okay, only read systems are there. Okay, so don't let's take not only 10, let's take is make is this as 100 databases are there. So in such cases, do you think is, I mean, propagating to each and every databases, won't you think that would be a lot of time, right? So what in real case scenarios, what generally companies do is they follow something known as what do we say? I'm forgetting that term. A concession or algorithm. Concessions or concession. That is what you might read about this one. Okay, consensus. Yes, exactly. That's the one. So what happens is that there is a mechanism. They say that whenever the read happens onto that, you can configure, right? Whenever the read happens onto, let's say, out of 100, let's say even if 50 are responding that this is the most recent question, just respond that this is the latest data. Don't read each and every one. Basically, out of 5 database, if 2 or 3 are responding, majority of them are responding that this is the data, and if that's the only one, just respond it. Don't look at each and every database now. So you can think concession as one of the algorithm that databases uses. Okay, in case of this, there are so many this thing whenever, right? Hmm. And okay, so now this was about scaling of databases, and now let's talk about transactions in a database. Okay, do you know what is a transactions? Mm-hmm. Mm-hmm. Right. 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 Exactly. Okay, so now in transaction, um, let's segregate in SQL, no SQL, everything aside. Just we talk about normal transaction. So in transaction, we mainly talk about these four terminology. The name is called ACID, right? So what does ACID stands for? It stands for atomicity, consistency, integrity, and what's the other one? Durability. Okay, durability, right? So we generally talk about these terminology in case of transactions. Okay, so now in a transaction, your acid property should be followed. Okay, that's what they say. So now what does atomicity states in a transaction? Do you know? Mm-hmm. 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 Right. None of it occurs. Exactly. Right. Either if it happens to fail in between, it will roll back to its original state. Very important. It will roll back to its original state. Okay. So that was about the atomicity, right? Now consistency. What does consistency states? Mm-hmm. Yeah, tell me. So what will happen now? So basically, in consistency, what it states is that your database should always be consistent. That means, if, for example, you have credited rupees to someone else, for example this is you and this is me, your initial data was, let's say, 10, your data should be 12 now, and my data should be updated to 8. Okay, so both the things should happen. The data should be consistent in this way, right? Otherwise, if this is again 10, this is maybe 12, so this is not consistent data, right? So consistency should happen. If at any point it thinks that it's not there, it will roll back to its original state. The data should be consistent at each and every point, right? Right. And the next one is integrity. Sorry, not integrity, it was isolation, I forgot. Mm-hmm. Mm-hmm. Right. So that means, yeah, exactly. So this and this are two independent ones. They cannot interfere with each other, right? So you can think in case of database, don't you think it's so complex to maintain isolation between in a real world scenario? There is a database, for example, a bank database. There are so many transactions that are millions of transactions that are happening in today's world, but they are not interfering with each and every one. Can you think that it's so hard to achieve this? But out of the box, database engine provides us this facility. So you can think database engines are doing so complex works also. So it's the database engine who is doing it, not the database. Database engine means the power. There's a difference between a normal a database and a database engine. Okay, you can read about database engines more. I think the most famous one is MySQL InnoDB. That is very much powerful. That's just very famous also. Okay, and there are many such in, you can read about that. Okay, so this was about isolation and durability. What is the meaning of durability? Mm-hmm, mm-hmm, exactly. Very correct. Mm-hmm, exactly. Right. That means commit has happened. Right. Exactly. Most recent write. Once the commit has been made, persist in the database. Right. Exactly. You cannot afford to lose the data, and data is recoverable also. Exactly. So that's the correct term. So so we know about transactions, right? So that was about the database transactions. Now we will deep more into this when we'll study specifically about SQL and NoSQL, how SQL supports ACID properties, how NoSQL in some way supports ACID property but not to a fully, how SQL can compromise on ACID property if we go for more and more use cases. So we can study more onto that aspects more. So now next talk about indexes in a database. So do you know what's the indexes in a database? Hmm? Okay. So there is something called indexes. We will not touch deep into this. We will revise on our own, but I'll simply touch upon some important indexes. So in case of database indexes, what's the purpose of database indexes? Okay, let's park it for some other day. In the next session, we will cover up this one. Okay, I'll keep this for next session. The reason being, I will study more onto this part, and we can discuss more onto this. Okay, so you also note it down. You can also study in the indexes, because I know the basics of it, but I cannot explain in depth. But I wanted to cover this in depth. Okay, so by next session, I'll be ready for this one. Before that, let's talk about locking in case of databases. We were talking a lot about this thing, right? Read heavy, write heavy, writes and all that, right? So generally in a database, locks can happen at any level. What is levels in locking? That means you can lock an entire table. That means you have one table and there is data written, 1 2 3, all that, right? You can lock this entire table. This entire table has been locked now. Okay, so what will happen if you are trying to do anything? You will be allowed to wait for some time, that this is locked now, please wait. And you can think there are so many users that will be waiting now. right? At the entire table, the lock has happened, right? What else the lock can happen? It can happen the entire column. That means this is the table, and now this column has been locked, so this entire column had been locked. So now if you are trying to read anything from this one, those people will be allowed to wait now, because this person has locked the database now. Okay, not the database, the column now, right? In case of transaction, mostly in terms of either during a read you can lock, or during a write, depending on our scenario we can lock. Now how do we lock it, that we will see in some time. Okay, so at what level the locks happen is what we are discussing now. At the row level, that means your row has been this entire row has been locked now. Nobody else can read it or write it. Depending on the scenario, we'll see whether they can read it or they can write it or what else they can do, right? And then your entire database can be locked. That means a particular organization, for example this entire database, right, has locked the DB for anything. For example, any write cannot happen onto this database. This database can only do the read purpose, so they have locked those scenarios, right? Okay, so now these are the various locking levels that we can do. So now how do we lock in these things in a real case scenario? How do we lock, and why do we need a lock? The reason for needing the lock is basically we want our data to be consistent, right? In case of, so see, whenever you have a multi-threaded environment, or whenever you have someone who is updating the same resource, writing onto the same resource, reading onto the same resource, some place wherever multiple peoples are involved, doing performing this some kind of updation, right, performing some kind of write and all those things, then only this locking will come in. Otherwise there is no use of lock. If in case there is a single thread, right, why would you use a lock? Because only a single thread is there, no other interference by anyone and all that, right? So in simple ways, if you don't need a lock in this world, don't use complications of concurrency and serial non-serializability, non-serializability and all that. Don't make it so complex. But in real case scenario, we cannot achieve this use case, because we will need it. Because your website and all those, it's not that one person is using a website, so many people will come and use it, right? So we will definitely need the lock. So there is a need, at least, right, that we can think of, right? Even if you are using a, for example, single threaded Python application server you are running, right? But ultimately database level, you are, many people would be invoking, right, your database. So at least locking will happen at this level. For example, at this level you have enjoying a single threaded language and all that, right? I'm not sure in single threaded how the things work, but I'm just assuming, for example, a single thread is working. So you thought that my system is highly concurrent, means it won't cause any kind of non I mean what inconsistency, because I'm single threaded, no use and no all such mechanisms will happen. But your database at any point of time will need a lock. Just remember this. Okay, so now we know that we need a lock, right? So there are various types of lock we can acquire in a databases, right? And now these are the levels of lock. So generally their locks are of two type. One is called shared lock. This is also known as denoted by S, and another is um, exclusive lock. Okay, this is denoted by X. Okay, so now in databases, how do we achieve this shared lock? First, let's see what is shared and what is exclusive lock. Okay, so shared lock means that a particular row over here in a table, for example, you have acquired a lock. That means you are a user one, and your request has come and then acquired a lock onto this one, and now the lock is of type S. That means in a shared mode you are locking. Okay, so now for example my request came in, more user request came in, right? The name itself suggests shared. For what will happen it now, they can, so this person has come to read the data, this person has also come to read the data. Now everyone has come to read the data, nobody has come to modify the data. All the person who are available to read, because this person has acquired a lock. That simply means everyone is allowed to read the same data, but nobody is acquired to alter this data. That was logged only for, that means if a user 5 has come and it is trying to update the data or write the data something, is not allowed. So this is basically not allowed. Why? Yes, but cannot write to it. That means it cannot alter the entire row. I have acquired the lock at the row level, so at the row level it cannot acquire the entire row, but this person can update the data at this row. For example, this row, right? This person can acquire the data at if we have acquired the data at the row level. If the entire table was locked, I think most of the cases the tables are mostly locked, not the row level. Okay, I'm not sure at what levels in the internals of database, I don't know, but just remember that if, for example, I think in most of the cases the entire table has been locked. Okay, so row or table, I'm not sure, but we can think through in what cases what we can do. We can actually research more onto that. Okay, just remember that this person cannot update anything. Whatever the user 5 has just come, right? They cannot update anything related to whatever log read that is happening onto this one. So this was about the shared log. That means so many persons are sharing it for reading purpose, but nobody is allowed to modify the data, right? And now in case of exclusive lock, what happens is, uh, uh, for example, there is a row. The reason I'm taking row every time is because I think it's easier to visualize. Otherwise, I think in real most of the cases, that particular rows that as I'll come to that, what I mean to say. That means this user has come to write, and now it had acquired to lock the particular row only for write purpose. Okay, now user 2 has come to write, user 3 has come for read, user 4 has come to update is basically I think write only, user 5 has come to read. So now user 1 has acquired to write, right? So now this user is not allowed, this user is not allowed, this user is not allowed, this user is not. Only the user that is allowed is this, because that person has acquired the lock u1, and that is for write purpose. Okay, so now you see what's the advantage and what would be the caveat of each and every type of lock that you are acquiring, right? Now can you think which systems can use which kind of lock? Very good. You can think of, I think, in case of book my show ticket, whenever you are making not making exactly the booking, but you are checking what's the seat availability on all that, right? For that you can check the read log. That means these many people are reading, right? In that case I'm thinking can be used. I'm not sure in what cases we can use. So that's the important difference you can think of. I will also research where exactly they are used. Okay, but definitely you can think that exclusive logs are used by banks, that is for sure. Okay, so now in databases, how do they provide this functionality? That means if you wanted to use this feature, important thing, this is all happening at the database layer. Nothing is happening on the application level layer. Nothing is happening on your Python code that you have written, because in Python you might have logs. In Java we have tons of logs. Okay, so we are not talking in terms of application layer level code and all wise. We are talking, you have your MySQL database, out of the box they gives us this feature. Okay, so now shared and exclusive log, how can you use this feature? So basically the way you can use this feature is something like this. In I think in SQL you can write something like MySQL select star from whatever table, join table T2, and you can write something like on shared log or something, on shared underscore log. That's the keyword that you can use. Exact even I don't know, but select for share, yeah, it's for share. Okay, not log, select for share, it's then, and then at the end select for share. That means it you have. So what query, I mean, just a minute, let me write it down in a better way so that you can able to understand. So you can write like select id name and then address and all, and whatever column you write. From users you join address a on u dot id equals to a dot u underscore id for share, right? So now only this query you have written, that is it. Now you have acquired a shared log onto these columns whatever you have selected, and where the id is equal to this 50 u dot id or something. Okay, so that means whatever row that you are returning onto this, whatever rows are affected due to this will be logged. Nobody will be able to write or update anything, but you people can read the data. Okay, so just one line and it does the magic, right? That's how I mean simple it is to give us a shared log. And for this thing update, you can just write something like for update instead of for share. You can write over here for update or for exclusive or something. You can just check what would, I think for update is the correct term. Okay, and you are doing an exclusive log. Okay, very important point, this is the most important point now I am going to tell, right? In so always whenever you wanted your locking strategy, always perform on the database layer instead of having at the application layer, right? Application layer level pe you have the locking mechanism. What is application level layer thing, what I'm talking? Code, yes. Don't do lock on code thing. The reason being your application servers are all stateless, your data and all is not residing, but this is stateful system. On stateful system where your actual data is residing, this and your MySQL or whatever SQL that you are using, right, that is providing out of the box this functionality. Always use this feature compared to your code level thing. We will also use the lock on the code level also, but in that case that will come after some time. But for such cases, banks or booking payments, where we need a highly concurrent systems, we will need the lock at the database layer, because ultimately your data is residing onto database. And at the code level, if you are providing the lock and onto the database layer, if some other servers update the database, then by that time the things can go wrong, right? So always try to use the database layer locking that you are being provided, right? So this was about the data locking that you can think of. Okay, shared and exclusive. Okay, so now we'll talk more concretely about any anything to discuss or any points you want to bring it up over here. Okay, great. So now we can think about the more specifically onto SQL and NoSQL things. So what's the difference between SQL and NoSQL? Right, right. Relations, yeah. Yeah, and the usage, right? Now usage now our use case will depend on the type of data, the use case. If you see there are a lot of relations that is happening, id, primary key, foreign key and all that, if you think, right, the relational database is a good choice. And NoSQL databases, for example, you have a blob of data where not that much relations would be required. In all that cases we will go for NoSQL. Now important thing to be noted over here is that this NoSQL gives us very much benefits over SQL, and both of this actually can be used vice versa. But in most of the cases we prefer SQL. In case of your, whenever you need an acid compliant database, we go for SQL. And we don't, whenever we don't need any acid compliance or less relationships, you want your entire data to be blobbed together in case of JSON data, right? So in those cases we can go for NoSQL, right? In the generic way we can term this, right? So now SQL databases are kind MySQL or no, there are various SQL databases, right? Postgres, Oracle, SQL Server and all that. Now NoSQL has been recently developed a lot. There are different types. What are the different types of NoSQL databases that you can think of? KV store, Yeah, column. Right. Let's talk also about this. KV is key and value. For value can be of any type. Object type you can think of. Key is basically the primary key. Onto that you are going to uh, find out the data. Column database, there is another called columnar database. It's generally of, I'm not sure how the data is stored, but the data is stored in table, rows, and dynamic columns, and each row is not having the same schema. That means tables, for example, T1 is having the schema, same schema as in it can vary, right? Table T1 having different schema, so it's not necessary that uh, I mean, for example, your data, right? Your data is name, age, and all that, right? And in the same table, I am having my data. Only I have three columns out of that, and yours have five columns, right? So that is columnar database. I think Cassandra is a great example. They scales infinitely, and I think whenever you need a very highly matlab size mein, whenever you need a very size bulkier database, columnar database or Cassandra is the one that is used. KV stores are generally used for cache kind of scenario, or any kind. Yeah, right, Redis or any kind where you use an object storage or blob storage, where you just dump your data, that kind of scenario. There's another thing called document database, like MongoDB. So you can just document and dump the entire blob that you want, right? Exact internals even I don't know. I'm just talking out that these are the various types. Uh, Depending on our use case, we can think there's something called graph databases also, where I think relations are mostly concerned for a particular kind of. I think in social network people might be using it. Basically, yeah, page ranking, adjacency list that we have talked in terms in data structures, right? So they maintains the data in terms of adjacency list, and generally for recommendation systems these are used. For example, this person is recommending to this, and mostly the recommendation systems uses this. And this is used in wherever a lot of data is required, data points, lot of data points is required, right? For example, you are building something called as IoT applications, where a lot of data points has to be fetched, right? And then only you can come to a conclusion, yes, this is this thing. This use cases we have discussed. Document database, I think for mostly, I think for MERN stack, I don't know where exactly do we use. We can, you can read more onto this one. Okay. And mostly JSON, and this JSON data is mostly stored onto this document, and they can provide complex queries also. And indexes can also be provided over here. So that is why it is famous also. MongoDB is very much famous because it can provide indexes, secondary indexes. And MongoDB also out of the box provide ACID compliance, but not in that way. They don't guarantee an ACID compliance, but they say in some extent that they provide. Okay, so now we will see how how SQL provides us the ACID compliance, how NoSQL does not gives us ACID compliance. That is one thing. Second thing is, um, just a minute, just a minute. I'll uh, so yeah, so NoSQL and yeah. So important question that I wanted to discuss. These were the different types of NoSQL. You can just go through it and also go through when in what cases SQL and NoSQLs can be used, but in a generic way. Mhm. In a generic way, ACID compliance and relational, all those things we consider for this thing, uh, for our use case. Yeah, you were telling something. Mm-hmm. 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 uh, no, no. Yeah, exactly. In most of the cases you can always use relational databases, or excuse me, start with a relational databases. You can say that, for example, your post, for example, your Facebook post, right? You want your Facebook post data in such a way that all the data should reside at the same place, right? Your users data and all that should come over here itself, user ID one and all that, right? So whenever we want your entire data to be at the same place, then we go for NoSQL. otherwise we can, I mean NoSQL in the sense that the data is denormalized, that is what we say. Normalization and denormalization is another term I haven't touched till now. So normalization is basically you are splitting the data so that there is no redundant data stored anywhere, right? That was the key term. And denormalization means you are making the copy of your data replication to different tables, and you are ready to do it because instead of, if you are doing a lot of joins, right, that is a complex operation and that will take a lot of time. So instead of that, why not to replicate the data? For example, users data is also replicated over here inside your post table, right? But over here, if you see, you have your users data, you have your users id over here, and then the name over here. You can have easily joined this one, right, underscore user id. But now over here we are storing the users data also along with the post. So why we are doing it? Because we can afford this much amount of denormalization, because from the id of the post I can get all the data. Why to join and making a complex thing? Because this might reside in different db node, this might reside in different db node. Making a cross shard join is very much complex. I think I have not touched yet the the shards joins. uh, Before that, let me talk about this thing, uh, joins in case of databases. Let's talk about this point, just a minute. So how NoSQL scales? Before that, there's something called normalization and denormalization. Okay, so now normalization, just I have talked, right? Relations, foreign key constraints, integrity, and all that, right? And now denormalization, basically you are making a replica of the same data that just I was saying, right? This user's data was I am replicating, you can have easily received, right? So post over here, id, then content, and then user underscore id, and then more fields. Now you have users data, you have id, and then you have name, and then other data. You can have easily joined this data. For example, for getting the post, you are joining users data, you are also joining likes table to see how many likes are there, you are also joining some other data tables also, t3 t4, right? Then in between, if you see that you are doing a lot of joins, that is also fine, you are joining. Now the problem arises when you have the data resided onto different data nodes. This is node 1, this is node 2, different database. So this over here has contains users, this over here has contains post, right? Now very important thing, just remember, this is the most important aspect now I am trying to explain out of why your SQL and NoSQL segregates between these two, is that whenever you are using a relational databases, right, and now you have made a relation, you are trying to join the tables. Now the problem that will occur is that you, if you wanted to join the data, how are you going to join between this node and this node? What you will do is you will query onto this database first, then join the users table, but users table is not there inside this, right? You are going to query inside this table users data. So you have fetched your post data from here, d1, you have fetched your users data from here, d2, and now you are going to join it. This is what is called cross shard join, right? This is what is called cross shard join, and at any cost we cannot afford this. Why? The reason is this is highly complex and the most time taking thing. You can think like 5 minutes approx it will take to do a cross shard join and then get the data. So just remember, in case your data is splitted and if you want to join the data, never ever go for cross shard joins. Okay, so in that cases what we do is we store the entire redundant data also. Along with post, I store the users data in the same blob of JSON that I was showing over here, right? So same place we are also storing this. So this is why we are denormalizing it, we are replicating the data instead of splitting the tables and all that, right? So this is place where we are going to use a NoSQL, because this is the Mhm. redundant data. Yes, in case of denormalization, the places where we are okay to have redundant data, because I can increase the storage size, because storage is cheap, but latency we cannot afford, downtime of the application we cannot afford. So in such cases where we can store this denormalized data all residing in one place, no problem at all, just go for NoSQL in these cases, right? So in that cases what we can do is, you can have a long post data, right? That means you have you're having a this thing, a post data which is very long, right? And now it is having, let's say, 10 to the power 19 users are there, right? And sorry, posts are there, right? Now each post is having this data, right? So now what you are going to do is, you are going to shard the post data now. So you are going to, for example, user 1 to 10 to the power 5 is in this post data, the post data of 10 to the power 5 to 10 to the power 10 is in this data, 10 to the power now you are going to shard the post data, and post is having users data also. Okay, so you have sharded the entire data of a post instead of segregating the tables. The reason being, otherwise you might have to do a cross shard join, which we cannot afford. Now in this post, now we will do a this thing. We will make our load balancer strategized in such a way that that all the request of a particular post, if you want to fetch, will only go to this database instead of fetching onto this and all that. Whenever we are going to design a high level design, right? For example, we want to design a Facebook news feed. We will see how smartly they have designed the system, that it can fetch the data in a span of seconds. Okay, if they would have adopted this feature of cross sharding, they would have never achieved this feature of so much less latency, highly available system. That we will come to that in later part. So now this was about normalization and denormalization. In case of NoSQL, we go for denormalization because we are okay to have it, because data store is quite cheap, but our services are more and more, yeah, more and more should be available. We cannot afford a high latency system, right? So when to use SQL, NoSQL is clear. Now let's see. Now, do you know application servers, AWS instances? What do we say? AWS, what's the name? EC2 instance, right? Out of the box, they provide us this thing, auto scaling feature, right? You can configure that, let's say 75% utilization has happened, please span one more, right? But in case of databases, do you think, do they have such functionality? Are they that smart? Mhm. Exactly. But now they have evolved with time. Now, exactly. But now they have evolved with time. The popular databases, they have evolved so much that they can scale itself on its own now. That means if you see your data has increased to such an extent that now it needs to shard itself on its own. So auto scaling kicks in. And such modern mechanisms are adopted by modern databases of NoSQL mostly. So I think MongoDB, Cassandra, they now supports all that. Out of the box auto sharding. NoSQL mostly provide this feature. Okay, now whenever the SQL systems have seen that now NoSQL are providing out of this functionality, right? So now SQL systems, I think MySQL also, I think Postgres also. So now they also thought that they are going behind the race. We should also provide this functionality, right? Because they were going behind the race, everyone will start using NoSQL. Out of the box, they are providing this functionality, right? Auto scaling. So they were thinking that they might go out of the race. So what they did is they also provide out of the box no auto scaling, right? So now your data is increasing. Just give me the solution. Your data is increasing to a lot. What databases will do? It will try to auto scale. Okay, in case of auto scale, what will happen now? Databases are stateful system. Your request has come, this database was having facing a huge load, it just auto scales and then spawns one more. This original database is this one. Just a minute. So this original database is this one. Now a new database has been spawned, this two. So now what will happen? It will not only replicate the data, NoSQL database, right? So now what we'll do is, in case of SQL, we'll do, yeah. So now it has spawned the data. Now it will shard the data. That means from A to M data will go over here, from N to Z data will go over here. Data partitioning will happen, right? Out of the box, NoSQL are providing these features nowadays. Again, same thing, more data is coming, it will again shard. Database 3 has come in, now they will automatically do on its own. A to something, then from there to something, then from there to Z. This is one such I'm telling. Okay, so data will split it across these three. They are sharded, very important, not the replicated data, they are sharded. Database is automatically sharding. Okay, why I'm talking of sharding? Because they are stateful system, data is only consisting only on one node. Okay, out of the three nodes, the request should only go in only one node. What will happen if they go in all the nodes? And in case of database replica to find, not replica. So for example, consider this scenario. Why am I talking the data should reside only in one node, not in one node, in the sense that whenever a request comes, right, the load balancer should make a choice in such a way that it should go only to one particular node, not to every node. It will check line by line. The reason, what would be the reason in such case? Hmm? Yes, latency, right? Why will it search in all the nodes? There can be hundreds of nodes like this, right? Latency would increase a lot. Instead of that, wherever your data is there, just go to that node and fetch the data, right? So now, important point, how will it find out in which data it is having, in which node it is having the data? That is already maintained, right? This is database, the state is already maintained. That is what I have taught about sharding key, right? On that key, it is going to shard the data and it will find out, right? For example, over here, how many nodes are there? Four nodes, right? Yeah, three are there. Okay, three are there. So for example, my sharding key is such that the ID of the request mod the number of servers. This is the sharding key. For example, user ID 5 comes in, 7 comes in, 11 comes in, 13 comes in, 15 comes in. We'll mod each and every request with the number of servers. 3 3 3 3. So in which node it will go? 2 1 3 3 are 9, 3 4 are 12, 3 5 are 15. 0 is basically, you can think of the first node. Okay, this is node 0, node 1, node 2. So it will go to node number 2. That means data will be present over here. Data will be present over here. At one request, they are getting anything. This is one such sharding mechanism that I can think of on the basis of number of servers. More mechanisms are there that we will see in further sessions. Important point over here is, out of the box, NoSQL is providing us this feature, auto scaling feature. Now the SQL systems were seeing this and they also tried to replicate this exact scenario. They will also auto scale. But important point to be noted over here is that auto scaling comes up with its own con. What is the biggest con of auto scaling? Features, advantages that we have seen, right? So now let's think in this way, right? Why is SQL so much popular? Because of ACID properties. Banks always use SQL. Why don't they use NoSQL? Out of the box, they are providing so much facility. Why still people use SQL? Because of ACID property, consistent and all that, right? So out of this, right, so still your ACID property is compliant database we are giving to SQL, but not to NoSQL, right? But NoSQLs in some way they still provide, but we'll come to that. Okay, now why SQL is so much popular and ACID property we talk on this term? So just see in this way, right? Your data of SQL always reside in one node. That's it. Maximum what else you can do, you are going to replicate the data, but you are not going to shard the data. This is T1, this is again will be T1 only. It's data replication you are doing, right? You are not going to shard the data, right? So the reason why they are not providing us this auto scaling is they themselves will not provide. They themselves will say, I cannot provide auto scaling. Why? Because if they are going to provide auto scaling, they will compromise on ACID properties. How will they compromise? Let's see that. Right now, data, this and this database, think in this way. right? They should always be acid compliant, right? For example, an update has happened over here, okay, they should be replicated to this place also, right? So now latency will kick in a sync manner, data should be updating this also, right? So all this propagation should happen to both the databases, right? Then only it will be acid compliant, right? Now in case of NoSQL, they are giving us this auto scaling out of the box and highly available system. Do you think they can afford to wait to update this one? Now very important thing, they also have data replication. NoSQL, for example, this will also have data replication, okay? But the only thing is that this also will have data replication, this also will have, because if this goes down, this will come up, right, and take its place, right? So data replication happens in all the cases in SQL, NoSQL. Otherwise nobody will use any kind of data store if they are only providing one data store. Okay, data replication is also happening, but it is just that they are providing in an async manner, they are providing in a sync manner now, okay? And that is one thing. And second thing is, you might have heard about cap theorem, right? Now in case of cap theorem, if the why does cap theorem comes into picture, when your data is uh, partitioned, right? Now in a SQL system, your data is there inside in a one node only, so there is no partition tolerance that is coming over here, right? That means only in one particular node the data is confined to, okay? So over here there won't be any effect from the external systems and everything. But in case of here, if you see, there are various partitioning that is happening onto databases, right? So they out of the box provide, because your entire data is residing onto one database, so that is why they don't afford auto scaling and all that. Otherwise partition tolerance will come over here. But in case of a single node in distributed, right? So cap theorem applies in SQL, it does not apply because P partition does not come into picture because only a single node is there, right? But in case of NoSQL, your auto scaling comes in, your data goes distributed. Now multi-region support is also needs to be provided. Because of all that factors, your partition tolerance comes into picture, right? So you see the reason why they cannot afford, NoSQL cannot afford ACID property, because their data is distributed in many clusters and nodes, right? They, because if they think that they are going to auto scale also and they are going to ACID property also, they might need a lock. That means they might need to, if they wanted to provide ACID property, there should be some central authority. This is some central authority that it will check that the data between all of these are consistent or not, right? So MongoDB has provided this feature that in a some way they are providing ACID property in such a way that, but you have to lose on your availability of the system. That means why will you lose availability? Because this central authority has come in picture now. Because before responding to the client, first this will cross verify each and everything, then only it will respond, right? So that's the reason MongoDB is providing us consistent ACID properties. But it will say that you wanted to tune whether you need an ACID compliant or not ACID compliant. Not ACID compliant, out of the box I will give you highly available system, auto scaling, all the features out of the box I will provide, but I cannot provide ACID compliant. So if you want to use for normal, in most of the cases NoSQL would fit in, because we don't need a highly consistent database. Only in case of payment system and banks they go for SQL. Okay, we can always use Amazon DynamoDB kind of database. That's, I mean, that's a very famous key value store. Okay, so you see why ACID compliance is provided by SQL and not via NoSQL, because of this auto scaling functionality, because of this data data sharding functionality and all that, right? Because it can expand to a huge load, expand to a huge size. They are doing out of the box so many functionality that they need to compromise on ACID property. But in case of SQL they cannot compromise on ACID, so they are providing out of the box this functionality. Now MySQL is also providing auto scaling and all that functionality, but they themselves are saying that a little compromise on ACID will be there, because now you are splitting your data onto different nodes for ACID property, right? So why NoSQL scales up is, this is the reason why they are able to scale up. This is the reason they are compromising on ACID property, they are compromising on their consistency. And why no SQL databases don't scale that much compared to non-SQL? Because they cannot lose on their consistency. So that's the reason. Out of the box, NoSQL and SQL provides us this functionality, right? Easier to scale up in case of this thing, NoSQL, and easier to scale out in case of SQL. Scale out is vertical scaling. You can always increase the scale. So over here, if you see, they goes for vertical scaling, and these are all horizontal scaling. Depending on the use case we are going to use, but in most of the cases that you are going to design, you can always use NoSQL. Okay, you can start with SQL, but eventually you can use NoSQL. Okay, that's the parameters that we can use. Okay, and yeah, so that was about data store, databases, read heavy, write heavy system. Okay, I think we have covered most of the part, but there's one more thing about data storage layer, that is caching. This is a small topic, then we can go through this one also. I mean, any points that was not clear or anything till previous? Okay, so there's something called caching also, and now caching can happen at various levels. Okay, what all levels it can go through caching? Hmm. Right. Let's draw out the system and then see. Then let's see. Okay, this is your client. Let's see. This is your first. It goes to DNS. Then it gives me the IP address. It then checks to whether any static images are there, and then request goes to API gateway. Then it goes to load balancer of a particular microservice. Then you have application server. This is the storage. Let's take three app server. This is your storage. Server 1, server 2, server 3, and then you have the load balancer on top of DB layer. You have various databases. Right, now let's see on what levels the caching can kicks in. Yeah, tell me. Where in this layer? Mm-hmm. Of this one, after the load balancer of this one, caching. Okay, now, okay, so caching where, on each application server, or is it for common for all the them? Common. Okay, so over here one cache is there, you can think, and this is common for all of them, right? So this is one mechanism. Second, okay, second, then you can think of many. See, at this place I was just asking, right? Caching can be inside this also, most cache data, right, in an application server. This is 3 inside this only, right? Most frequently used data, right? Then on front of this load balancer itself you can have a cache, right? On front of this API, this you in load, it won't go to further, after load balancer it won't go anywhere, right? After this it will just route it, right? Right, right. It is, cache is just a key value player, right? Key and value. Key is, for example, I am taking user ID. User ID once post data is all here. Most frequently used, for example, most frequently used data. For example, a celebrity has just posted in, and the celebrity ID is 100, and most of the people would like to see that data. Why would you go to the entire route? At the load balancer layer itself, you keep it. At the API gateway layer, you can also keep it, right? Before even hitting your organization, yours related data is yours. For example, any data, not that critical data, but some static kind of data you can keep in front your CDN, right? So basically request is happening in this way. So first this one is happening, second this one is happening, third this one is happening. That is the entire flow, normal architecture. Your CDN is coming into picture number 2. So one CDN itself is a cache. The most of the static data, iPhone 13 or 14 is going at 39,000, right? That's some static data, very much static. Every time whenever you pops up your Amazon, it will always be seen. How you are able to see so quickly? Because it is stored at the CDN, cloud front of Amazon. They are placed at the CDN. They are regional, very important. Your service is deployed, for example, in US Ashburn, but you are calling from India. Your DNS, sorry, your CDN is only present in India. It will not even route to this US. CDN is most popular cache. Let's not underestimate the power of this. Most companies use CDN. Okay, that's the very famous cache. Even you, the Hotstar Premium, sorry, Hotstar, this thing. Whenever you view any live matches, right? They uses CDNs a lot. A lot means a lot. Okay, CDN Akamai, the reason why Akamai is so much famous because of their CDN properties. So don't underestimate the power of CDN. CDN only is used for caching purpose. Okay, you can also use it at the DNS level. Okay, then I think, yeah, one more is on the client browser level also you can use a cache, right? Then over here on materialistic views are, do you know what is materialistic view? On top of each and every database, views are there, materialistic views. So they are also kind of cache, right? So materialistic view means you have just whenever you have a very common query that is happening every time, right? Instead of doing a query, you have data populated in a kind of view. Just call out that view, select star from that view, that's it. And that view is having a complex query. Yeah, that's view. Okay, so if we have seen line layers of caching to be used, you can think, right? So at these places, caching only purpose is to make your queries, make your request response model so fast that it does not hit your database. In some cases it has hit the database, but I think in most of the cases it will not hit, right? And the requests are very much faster. The entire user experience has been evolved a lot. You know, even in some of the cases, 95% of the request only happens via caching. That's it. So a most 95%, and the cache it's refreshing on its own from the background. Okay, so now this was about the various levels of cache. Now caching can be of various types, right? Caching is something, now important point, why don't we use cache as the database itself? Hmm? Why don't we use cache as the database? Why do we have a database only? Why can't we use cache as the database? Exactly, exactly. Yes, so caches are storing the data onto a RAM. They are faster because of this property only. The reason they are faster because of this property only. And the RAM's data is volatile, right? So that's the reason. Okay, so very good. So that's the reason we store cache. We use caches, but we don't as the ultimate persistent layer. Okay, so now caching mechanisms. So caching is basically a data replicated from the database itself, right? There are various mechanisms that we can use. So one is called write around cache. Now important point, cache is only used to get the retrieval of the get data. I mean, whenever there are get request, most of the cases we can also have for the slash post put also, but in most of the cases you will see caching to be used only for the get request. Okay, so for the get request, caching is always there, and for the write request we can think that basically the cache refresh from the database can happen via these levels. One is cache write around cache, write through cache, and then one is write back cache. So these are various levels that we can have. I mean, levels in this we will see. Write around cache is basically you have a cache over here, and you have a db over here, and you have a request coming. Okay, let's see. So first, there can be one mechanism in such a way that request one has come in, right? So it will first go and write to cache as well as to the database. That same request is writing onto both, right? Write request, read request will always go to cache first, and then check if it's not there, it will go to database anyway. Okay, so now written to both, this is called write through. That means this case was this one, write through. Okay, this is one such mechanism. Now for example, R is for request. Okay, let me write it down W so that you'll be able to understand better. Now there can be one mechanism where your write request has come in and it only writes to cache and then respond back, and now cache updates the DB, right? So this is happening in such a way: 1 2 3, this was 1, this was 1, right? So in that case what happens is this is called write back cache. That means at the back it will write to the database. Okay, responsible for writing, right? So each one is having cons and pros, we will discuss also. Now there can be one way that write request has come in, it will only do the write operations onto the database, and cache just sits idle. It when will it get hacked? Whenever you have a read request, it will first check if the data is there. If it's not there, it will go to DB and then refresh the cache and then respond. Okay, so this is another mechanism. In most of the cases in my company, I have seen this mechanism, writes right around cache. Yes. Now the reason is I think cache are, we cannot depend on cache for this such important activity. It depends on our use case, but most of the cases right arounds are used. In our company, at least I have seen this. Okay, so each one is having various pros and cons. For example, over here, con is basically, for example, in between, let's say your cache goes down or something, till that time your data got lost and it has not even wrote to DB, right? That one con that I can think of this. For this use case, you can think the latency would increase because it is writing onto two things, right? In case of write around, you might miss so many data miss, right? Because every time it is going to hit the database and then refreshing it, right? So that's the various strategies of cache that we have, and that is what I have to discuss on this uh, data storage layer. Okay, any other points you want to touch upon related to this? We can stop the recording and take a talk offline.